Hey there, welcome back to Decode. Coding is indeed not an easy task because that's what you feel when your code doesn't work. I'm pretty sure most of you have been there, and yes, nothing can be more frustrating than that. Have you ever been wondering why your code doesn't work? Or are you someone who has just started to code and is looking for questions and platforms to start with? Or are your technical interviews going on and you are already late with the preparations? Don't worry. Look, everything is fine. I am Kid from Decode. I'm here to help you. This is the next video of the series, How to Ease into Coding Along with Complexities. So, if you haven't yet checked out the previous videos from this series, do check out the same by clicking on the I icon above. Also, if you are new to this channel and haven't subscribed yet, make sure you do the same by clicking on the subscribe button and also hit the bell icon to never miss an update. So, now without wasting any further time, let's get started with today's video. In this video, we'll be discussing about add two numbers problem in LeetCode, which comes under medium category. If you must have gone through this question, you'll be knowing that in this question we'll be provided with two linked lists which are already set to be non-empty, and also it is mentioned that they are given in reverse order and there is no leading zero, and what we need to return is the addition of the numbers in these two linked lists. So for example, we have 342, that is 342, plus 465, that is 465, and the total sum goes on to 807. And as you can see, this entire thing is given in a reverse order, and this is what is to be implemented. So let's see what are the two ways in which we can implement the given question. Before we begin with the problem on linked list, let me give you a brief idea about what a linked list is to all the beginners watching this video. So in this problem, the linked list is described in the following way. It is described in the form of a structure which has two members. One is val, which denotes the value of the node of that linked list, which is of type integer. And we also have a next, which is a pointer of node type, which points to the next node of the current node that we are speaking. So, and after that we have three constructors, which I'll be coming in a while. Before that, just look at the linked list example that is given below. So we have a head pointer which points to the starting, the first node of the linked list, and these individual elements, the individual elements of the linked list that you can see, this 5, 1, and 4, all these individual elements that you can see, I've just brought one of the node. I've extracted one of the node and I have described that below even more better. That is the red portion, that is the number 5 of the node, denotes the value that is of integer type, and the link that you can see, or the next pointer that you can see, by default it will be null, but if there is one more node that comes after this current node, then this next will be pointing to that node, right? So with these two definitions, we come up with three more constructors for this structure, and the first constructor is without any parameter, and you can see if we call this list node without any parameter, then a node will be made with value 0, and the next will be given a null pointer. If we call it with a parameter of integer x, say we call it with number 5, then the value will be assigned as 5, and the next will again be set to, as usual, the null pointer. But if we call it with any value also, and we also call it with the next pointer, any pointer, any place we want to refer to, then the value will also be assigned, and also the next parameter, which was passed as an argument, will be assigned to the next member of this structure. So this was a brief introduction about what a linked list is. It is nothing but a collection of multiple nodes, and its starting is denoted by a head pointer and the ending is denoted by a null pointer. So cool, that was a brief introduction about what a linked list is. Now coming back to the question over here, since we are given two linked lists and already we know that both of them are non-empty and also don't have a preceding 0. So first of all, whenever we get a question of this type, the first question that needs to come into mind is what are the different cases we need to think about. First case is if we consider that there is no carry. Like over here you can see the first parallel nodes of L1 and L2, that is 2 and 5, constitute to 7, which is the parallel node of the output linked list, and this is a number which is less than 10 or a single digit number. And if we have such type of inputs, then the question is going to be really easy because it's just like adding those successive node values and getting the final output. But if we have a number, if we have the sum which goes greater than 10 or is no longer a single digit value, then we also need to get into the concept of carry, because that carry needs to be moved to the next upcoming nodes. That is, as you can see over here, the second parallel nodes of L1 and L2, which constitute to 4 plus 6, that is 10, which is having its single digit value as 0 and the carry as 1. Over here we need to make sure to send 1 as a carry to the next parallel nodes, that is 3 and 4, and that's the reason that gets added onto that, and we result into 3 plus 4, that is 7, and also carry 1 which constitutes to 8. So this is the second case, and we need to make sure to handle both these cases, right? So this is what we are going to implement in our code. So let's start solving this code in an incremental way. First things first, let us quickly declare the head node and also the output linked list that we are going to have. So as you can see over here, I have made a head node over here using the first constructor, that is the empty constructor, and using a pointer. The output pointer is pointing to that head node. So this is the first thing that we did. Also, we initialized the carry to 0 so that this can be used to store the carry that whatever we are going to get, right, while adding the parallel nodes of the given two linked list. Then what we are going to do, we are going to iterate through the entire two linked list, and we are going to check, that is the L1 and L2 that we originally have, we'll be iterating them through each and every node of the given linked list, and we are going up till when L1 becomes null or L2 becomes null. When will L1 become null? That is, as you can see down, somewhere down, we have L1 equals to L1 next and L2 equals to L2 next. Because of that, what will happen is this L1 that we have over here will keep on incrementing this way, and at a point it will somewhere reach null, and the same thing is going to happen to L2 as well, and that is the case we'll be checking over here. So we are going up till when L1 becomes null and L2 becomes null, and that's the reason we have put a case over here that the while condition should only work when L1 is not equals to null. That means either L1 still has elements or the L2 has elements. If either of the two has elements, still have other nodes as well, then we'll be continuing our operations. Then the second thing, the second line over here, the sum is nothing but it's going to add three things. As you can see, we have 1, 2 and 3. The third one is pretty much clear, the carry. If we have any previous carry which will be stored in the variable carry, that will be added to our current sum. Now you can see over here, I have just written some expressions. So some people must already be knowing what these expressions are. Basically, these are the ternary, this is the ternary operator. So the ones who don't know what a ternary operator is, let me even quickly tell you what a ternary operator is. The others can quickly just forward the video and see the rest of the part. So basically the ternary operator is nothing but a conditional check operator, just like the if condition, but we write this in a single line. So in if condition, we write the condition usually in brackets, and we write the condition in sort of these brackets, right? And then we open the loop, and in the first one it is if, and then if we want something else, then we also make a else block, and that is how things work. But over here what happens is we have a bracket. As you can see over here, we open a bracket, like just take up the first example. First we have y equals to 5, then we are writing x equals to, and then we have this ternary operator. The entire condition is enclosed inside a bracket. Now what is the condition checking for? First we are checking is y double equals to 5, and in this condition you can see, because first we have initialized y equals to 5, so this condition is true. So the red part is the condition, and if it is true, it is going to assign 6, because whatever is coming after the question mark is the one that will be assigned if the condition is going to be true. So the x is going to have the value of 6, and as you can see, when we did cout 6, we got the value as 6, right? And I've taken one more example. If y is 8, then if we follow the same ternary operator, it will again be checking is y double equals to 5. So here it is false, so 7 will be assigned to x, and that's the reason when we did cout x, we got the value as 7. So basically, if the condition is going to be true, then after question mark, the first value is going to be assigned, and if it is going to be false, the condition is going to be false, then after colon, the value is going to be assigned. So this is nothing. This is a short explanation of what a ternary operator is, and I've used this in multiple places in the following two methods, and that's the reason I've just explained that before in hand. So now what we'll be doing is, as you can see over here, we are first going to add these three, and I've already told you this carry is nothing but the carry that we'll be getting from the preceding operations. Now as you can see over here, since the initial condition of our while goes like even L1 can become null and L2 can become null at some position at some point of time, and that's the reason first we are checking if our L1 is not equals to null, then only we are going to add our L1 value, or else if L1 is equals to null, then we will be adding 0. So much must be very much clear, because I've already explained what a ternary operator is. So if our here, as we know, our L1 at the starting position is not going to be null, so our value will directly be added. So in this case 2 will be added, right? So at the same time, let me even iterate through the code. So our sum is going to have L1 value, also our L2 is also not equals to null, means this condition is true, so even L2 value will be added. So L1 value plus L2 value is 2 plus 5 7, and our carry is initially 0 only, so our sum is going to have the value of 7. Now in the next line, can you see that output next is equals to new list node? So before that, let me, as I just told you, the second in the second line we have this head and output. Let me quickly create this again in order to explain you how this was initially made. So because of this head node, we had this head node over here. Let me just represent this by H, as you can see over here, and that will denote the header node. And then you can see already our output is right now pointing at the header node itself. Then what we are going to do is, as you can see, once the sum was calculated, we have done output next is equals to new list node sum modulo 10. That means here we are calling which constructor? We are calling the second constructor, that is this constructor, list node int x. And what will that do? That will assign the value of the node that we are making to the value that was passed in the parameter, in this case sum modulo 10, and the next pointer will anyhow be pointed to the null pointer. So because of this, what will happen? We will be having output next, that is this output is right now at the head node itself. So next means this way we are going to make a new list node, and what is the value that new list node is going to have? Sum modulo 10. So what is sum modulo 10? What is 7 modulo 10? That will be 7 itself, because any value less than 10 modulo 10 will give the same value itself, right? So here we will have 7 itself in this one, and after that you can see output is equals to output next. That means now our O is no longer pointing at H, and O will be pointing at 7. This is the meaning of output is equals to output next, right? Let me just clear these all underlines so that the code looks a bit clean. And as you saw, the sum was initially 7. Cool. After that, what we are going to do is carry is equals to sum divided by 10. Because of that, what is going to happen? 7 divided by 10. What is 7 divided by 10? That is just going to remain 0, because it is not value is not greater than 10. So if the value is not greater than 10, then it's obvious that our carry will remain 0. So right now carry is 0. Cool. That much is done. And now what we are going to do, again use a ternary operator. And right now what this ternary operator is going to do, this ternary operator is going to basically assign the value to L1. That means if L1 is not null, so here we can see that L1 is still at our index 2, right? That is L1 by default was pointing over here, and L2, let me even denote L2's position. So L2 was over here. So both are right now not equals to null, right? So if they are not equals to null, by default the operation that is after the question mark will be assigned, that is L1 next and L2 next. So L1 will be assigned L1 next and L2 will be assigned L2 next. So because of that, what's going to happen? Because of that, L1 will now point over here and L2 will point over here. So this much should be very much clear, because that's what is happening because of this ternary operator, and that's how the code proceeds. So now again we go above and we do the same operations. So the updated values, let me quickly remove this in order to put now the updated values. So now the sum will be holding the value of 4. It's going to first check L1 is not null still, because L1 is having a node, even L2 is having a node. So again the first, that is L1 val, L2 val and carry. So what is L1 val? L1 val is 4, L2 val is 6. As you can see over here, the values L1 val is 4, L2 val is 6, and the carry is still 0, because the carry from the previous operation was 0, so it is 0. So 4 plus 6 adds on to 10. So now we get the sum as 10. What is the value? So after that, what we are going to do, output next is equals to new list node sum modulo 10. So let's first create output next. This output is over here because of the previous shift, right? And after the output next means we are going to create one more node over here. And what is the value it needs to be assigned? The value needs to be assigned as sum modulo 10. And what is sum modulo 10? It will be 0. So here we'll have a value as 0. And after that, same output is equals to output next. This is the basic iteration, like we have I++ for loops here. For arrays, right? For moving into the next indices, here we have output is equals to output next, because everything is connected through pointers, so we are just pointing it to the next pointer, right? And that's how it works. So now our output is right now pointing to this node which has the value of 0, right? Cool, that much is done. And after that, we are making carry is equals to sum divided by 10. And what is our sum? Sum is 10. So 10 divided by 10 gives us nothing but 1, right? It gives us 1. So our carry now becomes 1. And after that, we are just going to check again if our L1 is null, L2 is null. No, they are not null. That means the condition is true. So we'll again do L1 next and L2 next. That is, L1 will make it equals to L1 next and L2 as L2 next. So because of that, what's the thing that will happen? Let me just get rid of these things that has just come. Yes. So what's the next thing that will happen? L1 will now point to this final node and L2 will point over here. So we have 3 and 4, right? So the same operations again, that is L1 val in this case would be 3, L2 val will be 4, and the carry in this case will be 1. So that will add on to 8. So our output next will now become, will have a new node again. So output is right now pointing at 0. Because of that, output next, let me just make draw down because there is less space. Let me make a node, okay? And this node is going to have a modulo of sum modulo 10. So as calculated, what was the value of sum? Sum had a value of 8. And sum modulo 10 gave us a value of 8 again, because 8 modulo 10 is nothing but 8 again. And let us even calculate the carry now itself. Carry is nothing but 8 divided by 10, so it is going to be 0. So first of all, sum modulo 10, which needs to be the value of the node, let us write over here. So it is going to have a value of 8. And after that, we are going to do output is equals to output next, and that is nothing but updating the value of this output pointer. And now we are telling that output needs to point at just a moment. Yes, so output needs to point at output next. And what is output next in this case? Output next is nothing but 8, because output was first pointing at the node which had the value 0. So yes, that's all. And after that, again, when we are going to check this, L1 is null, L2 is null, and because of that, it will be since it is not equals to null, it will be assigned to L1 next again. And because of that, where will L1 and L2 point? L1 is going to point at this null that we have over here, and L2 also will point in this null. So as you can see over here, first it will check whether L1 is not equals to null, but no, this is false because L1 is equals to null. And then it will again check is L2 equals to null, and there also it will get false. Not equals to null, it will get false because L2 is again equals to null, and because of this while is not going to work. But after coming down, can you see we have one more if condition over here? But right now the carry is 0. We are not having a positive carry, means we are not having 1 as a carry, we are having 0. So this if condition is not going to work. And we are then going to return head dot next. So head dot next, head pointer next. So head pointer next, why? Because we are going to return this output linked list that we receive, which has the addition of the given two linked lists, that is L1 and L2. But again, coming back to the if condition, I just left out. Why that if condition we have included? In this case, we didn't get a carry 1 after we came out of the while loop. But when are we probable to get a carry 1 after exiting the while loop? That happens only when our last inputs, that is over here, can you see that we had 3 and 4, right? We had over here 3 and 4. And that with the carry, it just added up to 8. But here, if our value would add up to a value greater than 10, then we needed to add one more linked list over here, and that linked list would finally point to null pointer, right? So we wanted one more linked list over here, and then the carry would move on to that node. And to give an example about the same, I've just included an example below. So if you could see till here, till this when our L1 would be at 4 and L2 would be 6, that would just be like the previous one. You can again do it yourself, right? Just refer the previous explanation, try doing it yourself. I'll again be iterating from here. Cool. That is L1 becomes L1 next and L2 becomes L2 next, and because of that, L1 and L2 take the successive position. Let me just remove the previous positions. And then because of this 4 and 6, the previous thing, the carry will now be having a value of, just a moment, yes, the carry will now be having a value of 1. Cool. And even let me just get rid of these sum and val sum. Let's do it again. So what will be the sum in this case? It will be nothing but 3 plus 8, that is 11, and 11 plus 1, that is 12. So 12. So what is a value? That is when we just make we have to insert a value over here, right? So what that value will be? Value will be nothing but 12 modulo 10. So 12 modulo 10 is 2, and that's the reason only 2 will be entered over here, and then we will get a carry, that is 12 divided by 10, that is nothing but 1. And because of that, and after that, what will happen? What will happen because of L1 next and L2 next? Now L1 will point over here null, and even L2 will point over null. Because of that, our while condition will exit. This while condition is going to exit, and after we exit the while condition, then we get if carry is still 1, then do one thing, make output next, add one more node to output next and give it a value of 1. And because of that, what will happen? Where our output was originally pointing over here, you could just relate the same using the previous example as I pointed over here, that our O is right now pointing whatever O is there, and that is the output node is pointing right now at the last node. So O will originally be pointing at 2, and then what we are doing, output next. Output next is nothing but this. So we are going to add one node and we are going to give it a value of 1, as you can just see over there, right? It's given, and by default the next value is going to be null, and this is how this entire operation is done. So I think this must be very much clear why I had taken a carry equals to 1. That was just in order to, if the last node, right, that means, in other words, in simple words, let me just explain again, that in a normal mathematical language, if it is 3 4 2 and in reverse order, right, 3 6 5, so if our highest bits, that is this 3 and 8, add on to a value which is greater than 10, then we need to make sure to add one more node, right? Because we know that this will be greater than 10, and because of that there will only be some 3 plus 8, that is 2, and because of this, so here it will be 3, right? And after that, sorry, 2 only, 2, 3 plus 8 is 11, and because of the previous carry 2, and we'll have a 1 over here. Cool. So we'll have a 1 over here, and that's the reason I was telling that whenever the highest bit add on to a value which is greater than a single digit, we need to make sure to add one more node and assign it a value of 1, because that's pretty much clear. Even if you add two values, the highest value that both the node can have is 9 and 9, and your carry is never going to exceed 1. That is, it's not going to come in the range of 20s, so it is definitely going to be 1, and that's the reason I just made a new list node with a value 1. I hope it is clear, and let's go before we go to the next method, let us quickly calculate what would be the complexity for this solution. So if you look closely to what are the things that we executed in this solution, you can see that we went through the entire linked list, that is L1 or L2. So basically it goes up till the entire length. So the complexity would be order of n, and by n what I mean is the maximum of length of L1 and L2. So let me write the time complexity. The time complexity over here is nothing but order of n. This is the time complexity. And if let's discuss about the space complexity, can you see the space complexity over here? What is the extra thing that we have used? We have used a output linked list in which we are storing the sum of the parallel nodes of L1 and L2. And because of taking a output linked list which is the same size of the maximum of L1 and L2, so we are again taking a space complexity of order of n again, and that's the reason we have a time and space complexity both of order of n. So let us quickly go back to our LeetCode, and as you can see, this is the same solution. Let me quickly submit the solution and see what's the output that we are getting, so that we can quickly move forward and try the second approach. So as you can see, our code got executed within 48 milliseconds, and it has taken up a space of 70.4 MB, which is quite a lot. See, the time complexity over here is order of n, so we cannot actually reduce the time complexity. Okay, the time complexity is already the most optimal it can be, but we can definitely reduce the space complexity in order to make our code more optimal. Basically, these type of questions are asked in company technical interviews. So what they do is, first they give you the problem and they tell you to come up with a solution. Once you come with a solution, the second thing they ask you to do is how to optimize that. And although if regardless of whether you have to code or not at that moment, the main thing you need to think is what are the various ways in order to, whether you can reduce the time complexity and do some trade-off with the space, or can you reduce the space complexity and do some trade-off with the time. And that's how you need to think in order to optimize your solution. So let's see, keeping in mind the previous solution in which we had a time complexity and space complexity of order of 1, let's think what's the second thing that we can do in order to, as we have already discussed that the time is already in its maximum optimized optimized complexity, then the only thing that we can alter is the space complexity, and we can try to reduce the space complexity, or in other words, get rid of that extra space that we are taking, and rather just alter the original linked list that we have, that is L1 and L2. So let's see how to do it. So just like in the previous case, I told you what are the different cases you can just think upon. Let us, when we are trying to do something like this, that is just alter any of the given nodes, then we need to go even more deeper and dig on to all the possible cases that can happen, that can be given as an input to the program. All right. So keeping in the mind the previous code, I'll not be explaining this code that way, but I'll just be giving a slight overview. But before we head on to the code, let's come up to the cases. All right. So seeing in the first case, as you can see in case 1, we have 2 linked lists, and this is the same problem that is given as an example, and the one we did in the previous method. So here we have both the linked lists of equal size, right? And now you can see the second case. The second case is again the case that we just discussed in the previous method again, but the only difference is it had a carry, right? It had a carry in its maximum in its last node, and because of that we had to add one extra node in our solution bit. Right, now the third case that we have over here is the length of L1 is less than length of L2. The reason we didn't take case 3 and case 4 over there is because we were going till the end of both L1 and L2. That is, we were going up till L1 becomes null or L2 becomes null, and it was or, it was not and, it was or, and because of that, even if one ends, it was not affecting the operation of the other. But here, as we are altering and we are making one linked list to store the overall sum of 2 linked lists, so we need to make sure that this entire thing happens, right? So as you can see over here, case 3, we have the length of L1 less than L2, and in case 4 we have the length of L1 greater than L2, right? So one thing that you could see different in these cases and the cases that we discussed in the previous method was, here we have the resultant linked list the same, that is L1. We have altered the same L1 that we have everywhere on all the 4 test cases. You can see we have just altered the same L1, the L1 that we have just altered that. So what is the logic that we'll be using over here? Let us quickly look onto it. And what is the target? We have to not use one more linked list, that is the output linked list, which will be used to store the output, the sum of the parallel nodes of both these linked lists. So we are not going to use any output linked list, and rather than that, we are trying to get rid of that, reduce the space complexity to O of 1, that is having no other extra space, and that's how we can optimize the solution to some extent, right? So let's get started with this solution. So you can see we had made one more output linked list, but here we are and then assign the head to the starting, right? But here what we are doing, we are pointing the head to L1 itself, because that is something that will be returned later on, because even the return type is nothing but a pointer of the node type, and that's the reason we have already assigned the head equals to L1 only. L1, the starting L1, because right now L1 is in its starting position, and that's the reason we allotted head at this moment itself, so that later on we don't have any issue, right? Because L1 will be changing its position hereafter just because of that L1 next and L2 next, right? Cool. Then here this sum variable, although it is the sum, but here it will be holding the value of 2 things, both the things, that is the sum and carry. You could have also taken one more variable, carry, but I'll just show you how using a same variable we have just done both the things. All right. Here, as you can see, we have used while L1. This is nothing but L1 not equals to null, right? You can even write L1 not equals to null, because if L1 is null, this is not going to work. So while L1, that is when L1 is not equals to null, that means see, it's quite evident that this will work fine for the first case and second case as well, because I'll just even explain why it will work fine for all the cases. But let us look at the most, most interesting cases that actually apply for this method. That is the case 3 and the case 4. All right. So where the length of any of the two linked lists is smaller than the other one. So what we are going to do, rather than equals to, we are doing a plus equals to. That means there we used to store it in carry, right? Here the sum is going to hold the carry, the previous operation carry in itself, and that will nothing but do a plus equals to. That means add itself to again the L1 value and L2 value that the newly emerged L1 value and L2 value that we'll be getting, right? So let me explain that again. Once we finish with the first iteration, in the second iteration it will be pretty much clear what is exactly happening, right? So let's do one thing. Rather than rushing up to case 3 and case 4, if the ones who have already understood how the case 1 and case 2 is working fine with this code, they can move forward and look my implementation for the 3 and 4. But the one who didn't understand yet the case 1 and case 2, look on to the solution that I'll be explaining right now. So let's get started, but before that let me just clear these things up so that it looks a bit clean. All right, so we are going to first check. Let me again initiate the values of L1 and L2. So L1 will be pointing here, okay, here, and L2 will be pointing here. So we have 2 in the as the first node of L1 and 5 as the first node of L2, right? So the reason I didn't check that L1 is null or not, because that is already being checked by a while condition, and if it is null, it will not at all enter this loop, right? So I'm not going to check it again, but L2 we are going to check because there is no condition checking for L2, right? So for that I'm again using the ternary operator, that if it is not null, then only we are going to add the value of L2, the node of L2, or we are going to add 0. So here we are going to do a plus equals to, since sum already initially had the value of 0. So now sum will be having a value of 0 plus 2 plus 5, which will result into 7. So we have 7 over here. Then L1 value will become equals to sum modulo 10. That means I told you we are just going to alter the same, we are going to alter the same L1, right? So now, although I have made it in the separate line, but actually in real computer data structure, the same L1 is going to get altered. So what I am going to make L1 value as, I'm going to make L1 value as sum modulo 10, and that means 7 modulo 10 is nothing but 7. So L1 value is going to become 7, as you can see over here. Cool. Then we are going to make sum divide equals to 10, and that is the reason I told you when the second iteration comes, that is going to hold the value of carry, because sum divided by 10 gives what? Gives the carry, and here 7 sum divided by 10 is nothing but 0. And when this second iteration comes, it adds into itself, right? So just think, if sum divided by 10 would give us 1, when it adds into itself, it's also adding a carry, and that is how this sum variable is acting as the value and also as a carry over here. Cool. You gotta also use one more carry variable and store the value of sum divided by 10 if it's confusing. That's an easy thing that you can do. Cool. Now here are a set of 2 if conditions that I've used. I think this L2 next and L1 next must be quite clear. L1 next I'm doing by default because this is L1 keeps on going, but L2 next I'm only doing after checking L2, and this is same again as L2 not equals to null. That means L2 should have not ended. If L2 ended, then why are we going to the next? We'll not be going. So only if L2 is still there, then we'll be we'll be updating the pointer value to L2 next. After the first iteration, one thing must be pretty much clear, that is our first case, that is when L1 length and L2 length both are going to be equal, then that is just going to resolve between these and these things, right? It is not going to affect the rest if and else if part, because as and when it just reaches null, that is L1 next becomes null, that is L1 is right now in its last position, and also L2 next becomes null. Here you can see we have also added the sum, and this sum will only get true if it is a value greater than 0 or a positive value. If it is 0, then it is going to be false. So in the first case, definitely this else if is going to be false. So that's the reason the first case is not going to get affected by either the if condition or the else if condition. So the first if the case is just going to work for these set of codes and these set of codes. All right, that must be very much clear because we have done the same thing in method 1 as well. Now let me come quickly to the case 2, which we handled over there using a if condition in the last, right? Let me just show you again. And this was how we handled in the previous case using the if condition. This if condition that you can see over here, right? Using this if condition, we handle the case over there. So here how we are going to handle the same thing. We are going to the second else if, the else if condition that you would see, that is when our L1 next becomes equals to null, and also our L2 next becomes equals to null, and our sum sum is a positive value. That means here we know that sum can only be 1. So if sum has a value, then what we are going to do, we are going to attach a new node just like over there, and we are also going to make L2 equals to null. And as if you must have already noticed, even in the if part we are making L2 equals to null, and I'll tell you why we are doing L2 null, and that's the reason we are also checking for those L2 not equals to null and L2 equals to null in the conditions, right? So again, let me just get rid of these things so that it looks quite clean. Cool. So after having said this else if part, I think even this case 2 must have got clear. Now the tricky part, that is the case 3. Case 3, we have L1 less than L2. Then what is a possibility? There is a possibility, if you must have looked the if condition properly, that if our L1 next become equals to null, but our L2 next is not equals to null, that means L2 still has values, because if L1 was here and then L1 reached here, then L2 also was here, but L2 still has a value, but L1 doesn't have a value. Then in such case, what to do? In such case, because we know that our while condition is only working for L1, and if L1 ends in such a case, then the while will also end, and we are in short updating the value of L1 itself, right? So L1 should have the length of the greatest the length of the greatest linked list out of L1 and L2. So how to do that? What we will be doing is we will make L1 next equals to L2 next. That means since L2 was over here and L2 next is not null, it has a value of 5, but L1 next is null, so we will make L1 next point to 5. That means now what will happen? This L1 was originally small, having the only node as 8, but now it has a node of 8, 5 and 3. But the question arises, L2 is still pointing over there, and to just stop that, we have made L2 equals to null. So now L2 is not pointing anywhere, L2 is equals to null. And the only part that was not discussed is why we have taken this L2 equals to null and L2 not equals to null. The first, in if condition, the reason I have included this L2 not equals to null is because if L2 has already become null by any reason, then if you are going to check L2 next not equals to null, you will be getting an error that you cannot check the next property of already null object, right? And that's the reason first we are checking if L2 is not equals to null, then only we are going to check if L2 next is also not equals to null. And the reason I have taken L2 equals to null over here, because just because of this if condition, if all the nodes, the succeeding nodes of L2 were assigned to L1, because L1's length was small, as in case 3. Basically, if L1 ends and L2 ends, and still we have a carry, right? So that will also be applicable if L1 ends and L2 is already null, and still we have a sum variable. So for both the things, it needs to work, because and that's the reason we have used a OR operator over here. That is, if this is true, or this and this is true, then for both this condition, this else if should work. So let us quickly discuss what would be the complexity over here. So I think it must be quite evident that the time complexity will still remain O of n. The reason being that we are traversing through the entire length of L1 or L2, whichever is greater, and this is the time complexity, right? And what will be the space complexity? The space complexity over here will just be order of 1, and that is something that we have optimized in LeetCode. So let me just comment the previous code and let me just uncomment this code in order to see what will the final output look as, and will it be more optimal than that. So you can see that the runtime did vary, but that is probably a lot of factors does affect that. But if you see the space complexity, it is very optimal because it is 69.7 MB, which has been reduced to a lot of extent, and it is less than 94.32% of C++ online submission. That means we have reduced the complexity of our solution to a greater extent. And yes, that was all with the two approaches that I had to discuss for this problem. So if you like the approach, if you like this video, make sure you hit the like button, and also let me know your valuable comments in the comment section below. Also, if you got a better approach than this, let me know the same in the comment section below again, because I'm always open to learning. And all those who have yet not subscribed, make sure you do hit the subscribe button and also hit the bell icon to never miss an update. I'll be meeting you shortly in the next video. Till then, bye-bye. Take care.